Okay, in this lesson we're going to solve linear quadratic systems graphically. So what does that mean? Linear, straight line, quadratic makes a parabola. Solving a system means graphically finding the place where these two shapes will meet, so the points of intersection. So first of all, there are three scenarios that can occur. We can have two points of intersection like this, where our straight line hits our parabola at two places. We can have one point of intersection where our line just touches or grazes the parabola at some place and just hits at once. It could even be like this, where it just nicks it at one spot. Or you could have a parabola such as this one. Look at this one that's opening up, and this one below it, and they're never going to touch, so zero solution. So we can get 2 points, 1 point, or 0 points. All right, now, everything in this lesson is a skill you're supposed to have already. You should already know how to graph a parabola from grade 10. You should already know how to graph a straight line from grade 9. So right now in grade 11, what you're getting marked on and credit for is how good a job you can do on that. So really, if you can draw a parabola in a straight line and do a neat job and label all your important stuff, it should be an easy perfect for you. So let's review the kind of things that we're looking for in our class. Are you using a ruler for the lines? Are you drawing arrows at the end of all your graphs, right? All the parabolas and lines you're drawing. Label the coordinates of the point of intersection on the graph. Okay. Label the functions at one of the ends. And all graphs must fully extend beyond the grid to receive full marks. So these are the things you're really being marked on. So this should be pretty easy. Just doing some grade 9 and 10 skills. Just one final time in grade 11, making sure you actually can do an adequate job of that. So I'm going to do two quick examples for you. Okay, so here we go with our first one. We got f of x and g of x. F of x is our quadratic equation. G of x is our linear equation. And again, the goal is to do it graphically. Yes, algebraically is faster, it's more efficient, it gives us better numbers, but that's not what you're being evaluated on here. You're being evaluated on your ability to draw a half-decent graph. All right, so let's start with our quadratic one, the f of x. So I'm going to go through this pretty quick because we've already covered in other lessons, but I start by finding my axis of symmetry. There's multiple ways you can do this. I just like to use the shortcut formula. X equals negative b divided by 2a, and a is 1, b is 10, c is 22. All right, so I've got negative 10 divided by 2 times 1, so it's going to be negative 5. So I know that's the x coordinate of my vertex. I can find the y coordinate by subbing in to find my minimum. How do I know it's a minimum? Right, so this is my y. And how do I know it's a minimum? Because a is positive, it opens up, right? So our parabola is going to look something like this. Okay, so let's just sub in negative 5, and I have negative 5 squared plus 10 times negative 5, so that's negative 50 plus 22, and we're going to get negative 3 out. So that tells me my vertex is negative 5, negative 3. Great, negative 5 over, negative 3 down. All right, so there's our vertex. Now, to find more points, I'm just going to use our shortcut pattern that we've already talked about. So the shortcut pattern to find more points, right, is 1 times a, 3 times a, 5 times a. So a is 1, so 1 times 1 is 1, 3 times 1 is 3, and 5 times 1 is 5. So every time I go to the left and right one step, first I'm going to go up 1, then 3, then 5. If this doesn't sound familiar to you, go back and watch the video where I explain this in more detail. And there's lots of resources on the internet, and they call it the step pattern for quadratics. So I've gone up once, then I went up 3 times, now I'm going to go up 1, 2, 3, 4, 5 times. Now, if you wanted to go again, the next one in the pattern would be 7, but that's going to go off our graph. So generally 1, 3, and 5 mostly get the job done for most parabolas. All right, so do a really neat job. I know I'm having trouble with this pen. I was never the neatest when I was your age, but make sure you, oof, that's not great, but make sure you go through the points, right? Actually go through the points you've drawn on the parabola, on the graph. Notice how I'm going off the graph, and I'm putting arrows on the end. That's one of the expectations we listed. All right, and let's label it. So I'm just going to call it f of x. All right, great. There's my parabola. Full marks there. Now let's do our straight line, which is g of x. All right, so what do we have here? Now, there's lots of ways you can graph a straight line. I'm not going to review all of them here. That's covered extensively in grade 9 and grade 10. So I'm just going to quickly go through it. And if you need extra help on that, you know, just have a look back at, just do an internet search even, right? We've covered this a lot. All right, so this one has a y-intercept of 0, 4. All right, 0 over 4 up. And I'm going to use the shortcut because the slope of this one, the m, is 1, which means it's 1 over 1, which means it has a rise of 1 and a run of 1. So every time I go over to the right one, I go up 1. So over 1, up 1, over 1, up 1. Oops. Right, over 1, up 1, and I can keep finding points that way very quickly. I can also reverse the steps and go backwards, down 1, and to the left 1. All right, so there we go. Look at all the points I can find. Right, I've done a pretty thorough job there, a little more than is necessary. Draw a line all the way through the graph. Make sure it actually goes through your points. This is where you want to use a ruler, okay? And put arrows on the end. Notice again my line is extending past the grid. See, I got my arrows on the end, and we'll label that guy g of x. All right, so there we go. The final thing to get your full marks, hopefully you can draw your points a little neater than me. I have trouble on this program, is to label the points of intersection. So one of them is right here at -6, -2. And the other one is up here at, what do we got there? -3, 1. All right. There we go. That's what I'm looking for full marks. All right, I'll just do one more with you, and that should be enough for that. Okay, here we go again. We're going to be graphing function h and j. Now, function h is my quadratic, so let's start with that. A is -2, b is -28, c is -89. Now, if you remember, c is our y-intercept because if we substitute in 0, what will be left is -89. That's not going to fit on my graph. But let's start by finding the axis of symmetry, which is a vertical line. It also tells us the x-coordinate, so both of those things. The x-coordinate of our vertex, -b divided by 2a is our shortcut. So -28 divided by 2 times -2. All right, so we end up getting -7 out of that, right? All right, let's find in this case, we're going to have a maximum. Why do we have a maximum? Because a is negative, so this is going to open down. And that means that gives us our y-coordinate. So here we go. Let's substitute in to find y, or in this case, we're using h of x. So if I want to be technical, I really should write it like this. H of -7 equals -2 times -7 squared, minus 28 times -7, minus 89. Do all your calculations. I'm just going to write down what I got in the end. I got 9 out. So that tells me my vertex is at -7, 9. Great. So -7 over 9 down. Where are we at here? Wait a minute. -7 over 9 up. I'm like, that's not going to fit very much. -7 over 9 up. Sorry, guys. I'm starting to fall asleep. If I make mistakes, please don't be afraid to comment in the video or on our class site. You know, doing a bunch of these a day. It's not a good excuse, but I definitely have stumbled and written things down wrong, and I do really sincerely appreciate those of you who have pointed them out to your classmates. It helps me and them. All right. Let's use that pattern again. Remember that pattern we were using? The pattern is 1a, 3a, 5a. Well, a is -2, so 1 times -2 is -2, 3 times -2 is -6, 5 times -2 is -10. So we're going down this time because our pattern's negative, right? And a is negative. So the first time I go to the left and right once from my vertex, I go down 2. The second time I move to the left and right, I'm going to take 6 steps down. So 1, 2, 3, 4, 5, 6 from the previous point. All right, and there we go. The last time we're going to go down 10 steps. So move over 1 and go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so that's really stretched out. Try to do a neat job. Right, drawing our, there we go, parabolas. Go beyond the grid lines, please. Include arrows on the end. Why do we include arrows? To indicate that this will continue past the grid. Notice how even the grid I'm using has arrows to indicate the x and y axis will continue. All right, so let's just label it. The nice thing about using function notation, we can just label it with its function name, which is h. All right, let's graph this guy here. Now again, what's his y-intercept? It's 0, 6. All right, so 0 over 6 up. And what's this guy's slope? The slope is -3 over 7. So if I put the negative on the numerator, that means my rise is negative. So I'm going to be going down 1 every time. Since this is positive, my run, I'm going to be heading to the right 1, or right 7. So if I go down 3, 1, 2, 3 steps, step over 1, 2, 3, 4, 5, 6, 7. So there we go. Now, we can also reverse this, right? Because think about it. Let's just review some grade 9 stuff. What if I stick the negative on the bottom? Then the numerator would be positive, right? So that means if my rise is positive, I'd go up, but my run is negative, I'd move backwards. So if I move backwards 7 steps, 1, 2, 3, 4, 5, 6, 7, up 3, there's the point. All right, so let's draw a line through it. And again, the point of this is not just to get the solution. I'm really giving you your grades for doing a neat graphing job to just verify one more time that you in grade 11 can handle doing grade 9 and 10 graphing. All right, so I'll just label this guy J of X. Now this one only touches once, and it touches the vertex. So it touches it right there at the vertex, which was negative 7, 9. And there we go. That's all I'm looking for, but do a neat job on your questions yourself. Thank you very much, and check out the next video.